GM. Thank you for being here. So I'm Christoph from Flashbots. That is...
Another Sybil from Flashbots.
Okay, I know him under the name Bruno, but that might be wrong. Today we want to talk about spam. Best thing to start is with an example. That is January 31st, Arbitrum Block Explorer. January 31st was a day where there was quite some activity in the markets, and you had a lot of liquidations at that date because prices were moving a lot. And that is an Arbitrum block, part of an Arbitrum block, during peak liquidation times. And what you observe in these kind of blocks, this block contains 700 roughly transactions, and they do literally all of them do the same in slightly different ways. They are bots, but what they do is they check for Oracle updates. So they ping the contract of Chainlink and want to see whether there was an Oracle update, because they will expect soon there will be an Oracle update, and once this Oracle update is triggered, we could liquidate a bunch of lending protocol positions. They do it all in slightly different ways. So some of them check Oracle contract, see nothing happens, revert. Some of them check Oracle state, see nothing happens, do nothing but don't revert. All kinds of different bots, but they all do literally no state transition. So the state isn't moved by these 700 so transactions. Okay. If you like a visual, that's risky, but if you like a visualization. So that's sort of if you want to think about your standard Arbitrum block, right? So you have a bunch of transactions that somehow make sense, and a bunch of transactions that look a bit like spammy. And that is sort of this high liquidation, peak liquidation block in Arbitrum. It fills much more rapidly, and basically none of those transactions change state in any meaningful way. Okay. As I said, January 31st, that was this peak liquidation event. And that is not only Arbitrum. It happens on a bunch of L2s as well, right? A bunch of other L2s. And you observe similar patterns. So you observe basically blocks full of bot transactions that only check for Oracle update and do nothing. And you observe basically that a lot of the traffic on these days, up to 1/3 of the traffic on these days, is created by those bots, right? You observe it in the gas statistics. Gas increases as reaction to that because a lot of it is consumed by these bots that don't do much, looking for Oracle updates. And as I said, there are different variants of those bots. So in Arbitrum, they tend to, it has to do with the architecture or the EVM, but on Arbitrum, they tend to revert rather than not doing anything. On base, they tend to do nothing, right? But it's sort of, that's not a very important, consideration. The fact is they don't change state, but they just put transactions on chain. Question, is it spam? Spam literally, if you think about, classical example like email spam, right? There is basically you receive unelicited messages. You didn't want to receive that advertisement, you don't want to receive that phishing attempt, you didn't ask for it. The L2 sort of ask for transactions, right? They post a price. Everybody can include whatever they want on that chain, and you might as well include your attempt to read Oracle state on chain. L2s are open for business, so nothing bad is happening. So in this sense, it's not spam, right? It's explicitly elicited traffic. Okay. I don't know, in the end, is it spam or isn't that spam? What is spam anyways? I don't have, answer to these philosophical questions. But one question that we could ask instead, okay, there's something weird about it, right? That doesn't look optimal. That doesn't look like good chain design. That doesn't look like something we should strive for. And I motivated it with liquidations. That's not the only way bots try to do this optimistic MEV extraction, right? They also try that with backrunning trades on a pool. So they optimistically spam the chain, check whether somebody has touched a DEX pool, and if they are lucky, they want to backrun that transaction, right? Same pattern, okay? It's less spiky in the sense that it happens more like uniformly over time, but same pattern. And so what could be wrong about it? I mean, if you think about efficiency, it sort of looks a bit wasteful, right? It looks a bit wasteful. It's very salient in the liquidation story. So there's literally, I don't know, a handful or even only one bot that can liquidate all of those, I don't know, Aave positions. Still, there are gazillion transactions that try to perform this liquidation, but only one of them wins. And the other ones, I mean, seem to be wasteful, right? We only would have needed one transaction that backruns an Oracle, not like thousands of them. Okay, there's some waste, you could argue, from the point of view of the searchers. Still, it's a very lucrative business for them, so maybe it's not that wasteful after all. From an infrastructure perspective, the chain sort of suffers because some resources are used that arguably shouldn't be used to, I don't know, do these kind of things. Most salient one, I would say, is history growth, right? If that happens a lot, and if you want to run an archival node, I mean, it just blows up how much transactions you need to keep track of. And all of those transactions are part of the history. They don't do anything. Still, you need to keep track of them. So that's bad. From a sequencer perspective, if you are at this peak load times where everybody is waiting for the Oracle update, they can have to carry a lot of transaction load, right? So that might lead to things like delayed blog posting in some L2s, and that might lead to just higher infrastructure cost in general of running the sequencer, so that's not good. If you want to use the chain while somebody is heavily spamming it, right, it's very bad UX. You know, gas price is moving very rapidly. It's a moving target, right? So I don't know, you don't know how to set your gas settings to get included. It's full of spams. Full of spam means other people might be crowded out. And you could argue, okay, it's probably a very bad mechanism to capture that value that is obviously created by liquidations, right? Liquidations have an economic purpose, so it's reasonable that we do Oracle, we check for Oracle updates and we liquidate positions. That's a healthy thing to do. But the value that is created by doing that, I mean, that could be internalized probably in much more clever ways. Okay. How is it related to design of these chains? So Arbitrum case is very straightforward. It's a first come, first serve chain. They have this time boost product, but that is not really used for these kind of liquidation or probabilistic backrunning strategies. The problem is in the first come, first serve chain, you cannot express the preferences of the kind, I want to be placed behind a certain target transaction that might arrive in the future. There's some opportunity, I'm sure, will arrive in the future. Once it is there, please put my transaction behind it. I cannot express such preferences in such a sequencing design. If you have PGA kind of architecture, like in Bayes, actually it's quite similar, at least in the liquidation story, because people have, or searchers have a very good way of figuring out, okay, what are the gas settings that they have to match in order to be placed right behind a certain, I don't know, Oracle update or backrunning trade. So they match on gas, right? But many of them know how to match the gas. So it's not a competition on gas, right? So because through PGA you cannot express to be behind something particular, right? You can only express to be placed on top of the block, so to speak. So many people match the gas, and then it's basically a tiebreaking race. And usually, if you spam a lot, you have higher chances of winning as a tiebreaker. Okay, that's the mechanics. Quick side note, I mean, I talked about L2. Actually, spam is happening on L1, right? We work at Flashbots, we observe it at our builder, but it never hits the chain, right? So builders do a lot of the filtering. And the other thing is we have more expressive ways of, for people to express their preferences of, I don't know, backrunning a transaction and so on. So we have auction mechanisms that allow to do backrunning arbitrage and express your preferences for that. But in principle, it's a thing also in L1. Okay, final slide, and then we go a bit into the theory. That is, I talked a lot about liquidations. But what is also, as I said, a very popular strategy is more this probabilistic backrunning on pools. So you expect, okay, somebody will move the pool, right? Somebody will move DEX pool. And once that has been done, there's an opportunity to arbitrage. And if you just track that, and that is something that our colleague Bert Miller did last year, this analysis, if you just look at this kind of sort of bot activity, it constitutes around up to a third of all of the traffic on those L2s at peak times. Has become a bit better. First of all, because bear market, there's less value to be extracted. Also, in reaction to spam, L2s have raised repeatedly fee parameters, right? And if you make it a bit more expensive to use the chain, you will elicit less traffic. Okay, but I think you see in the data that there is a significant amount of spam activity on these L2s, and we have to reason about it. And now Bruno wants to tell you how we could reason about it strategically in a game threading model.
Yeah, thank you. So we are researchers, right? So ideally, we would like to make predictions. We would like to analyze counterfactuals. And to do so, we need, well, a model. So here we have a very idealized model of how searchers do this type of MAB extraction. And the ideas of the model is quite simple. You have this representation of at time 0 is when the block starts, and at time 1 is when it ends. And you have an opportunity that is this value C that arrives stochastically between 0 and 1, and you don't know exactly when, but it has some positive EV opportunity, let's say $1. And the searchers can place transactions at any moment of time, but there is no information disclosure until the block ends, because it's a private mempool. And the searcher that just lands afterwards extracts the MAB opportunity. That's the idea of the model. And I don't know if I said it already, but each one of the transactions has the base fee cost or the priority fee that tries to match the opportunity. So the question is, well, what will searchers do in this model? Because if they wait too much, for example, they will wait until the information disclosure, it's maybe too late. Let's say you wait until time 1 to see where the opportunity and then instantly react and send a transaction. It's maybe too late, because if your adversary sends it at time 0.99 with high probability, it will extract it, and you will just pay it for a cost. And almost with 0 probability, you will extract it, right? So that's not ideal. And so what we did is, well, we formally defined this model and tried to compute like the equilibrium of the game. And something we find is, well, there is just one symmetric equilibrium, and it has a very beautiful form. First of all, it's not pure. What does that mean? It means that essentially people doesn't take like deterministic actions, but they actually randomize. They take random seed, and they decide, okay, where I will send the first transaction. But interestingly enough, they just randomize the first transaction when they send the first transaction. And at the beginning of the block, depends on the parameters of how valuable is the opportunity and the cost, but this is general enough. They randomize the first opportunity, and the next one is deterministic as a function of the first one. How this deterministic function works? Well, it's a solution of a differential of equations. No need to go into the details on that, but this is more or less the geometrical structure. Maybe the most, this is very interesting as a game theory, but maybe the most interesting thing as mechanism designers or as for L2 is that this spam, so the amount of transactions we'll see for extracting these opportunities is around the expected value of the MAB opportunity divided by the base fee cost. So just make the numbers for a $10 opportunity divided by a cost of 0.01 cent. That's a bunch of transactions. So knowing that MEB spam scales as expected MEB divided by base fee, what we can do as mechanics designers? Well, we have this subset of options, at least, that is first just better fees, so a better mechanism for updating gas costs. And the idea would be to adjust prices by resources. So isolating hot contracts from not very popular contracts and update them dynamically in a multi-dimensional fashion way. That will raise costs in just a subset of them, and therefore will reduce, essentially will reduce spam. Another idea would be just, yes, improve routing. Like a lot of MEB is being leaked because of inefficient routing. So that could, a solution could be to have just-in-time routing or on-chain routing, or just have backrunning auctions off-chain. I think this is already more or less starting to happen in liquidations. Chainlink is starting to expose the Oracle updates off-chain and doing a backrun auction. So probably in the future, we'll see a reduce of spam because of this. And a third solution is just making the uncertainty window smaller. The smaller it is, the smaller the expected MEB per unit of time is, and therefore also the spam will reduce. So as an I think this in previous graphs, we saw it more or less. Probably due to flash blocks, we have seen a reduce of spam, because essentially we have, where before we had just one block, now we have 4. So future work, things that we are missing. We have numbers on aggregate of how spam more or less works, but we don't have the full distribution. We don't have, okay, how much people is spamming per opportunity. And there's a lot of things to analyze, like, for example, how much actual surplus are searchers capturing, how profitable these opportunities are by searchers, and therefore, as a searcher, maybe you have interest on knowing this. For theorists, yeah, I think Christoph has already discussed it. We don't have a formal definition of spam in this context, so think about it. And also, we make a bunch of conjectures in the paper. Take a look, and hopefully you're able to prove it, either you or your AI agent. And yeah, for practitioners, just design better apps, or try to think, okay, what will happen in a regime with low gas costs? And think, okay, what will be the negative externalities of a bad design to the L1 or L2 your app is? And yeah, I think that's all for us. You have here the link of a blog post and a paper with all these models. Take a look.
So I wanted to shout out Thomas from Flashbots, Thomas Andal, who provided a lot of the data, and who used to be, back in the days, a very avid spammer on base. Shout out. Right, thank you.